Hey guys, welcome to the Chapter 6 review. We're going to go back over some of the key features from what we've worked with logarithms. I'm not going to go back through the full lectures, so this is just kind of an overview. If you've missed any of the lectures, you might want to get the notes from someone. But this should help you if you missed something or if you're just not really sure on what we've been working on. All right, so we're going to start with 6.4. That was where we started with logarithms. All right, and that's also the start of test 4. So the first thing that we're going to work on is going back and forth between logs and exponentials. That's this property number 1, where we define the logarithm based on the exponential function that we worked on in 6.3. Okay, so you need to be able to go back and forth between logs and exponentials. This is really important that you have this down pat because we use it for a lot of stuff later in this chapter. All right, so two things to notice. One is that the base of the logarithm will always match the base of the exponential function. Okay, so the base of the logarithm always matches the base of the exponential function. And the other thing to notice is that the logarithm is equal to the exponent. So there's our exponent there, and the logarithm is equal to the exponent. Okay, so if you remember where those two things go, then you should be able to convert back and forth pretty easily. All right, so let's try a couple of these. So let's say we want to convert to exponential. Okay, so we're just going to convert to exponential form. This doesn't have anything to do with solving equations or anything. So let's say we have like log base A of 9 equals 7. Log base A of 9 is equal to 7, and we want to convert this to exponential. So the base of the logarithm is A, and the logarithm is equal to the exponent 7. So to convert this to exponential, it's going to be A to the 7th equals 9. So A to the 7th equals 9. Okay, so let's try another one. Let's say we have log base 2 of x equals 12. Log base 2 of x is equal to 12. So the base is 2, the exponent is 12. So when we convert this, it's going to be 2 to the 12th equals x. Okay, so 2 to the 12th equals x. So this is just a pattern to memorize. You've got to do a lot of these to make sure that you have this down pat. There's a whole bunch in the homework that's been assigned. Let's try one with natural log. Let's say we have natural log of a equals 5, and we want to convert this to exponential. Now for natural log, you've got to remember what base natural log has. Natural log is base e. Natural log and e always go together. So if you want, you can write a little e in here to remind yourself. That might help you change it to exponential. So we see the base is e, and the exponent is 5. So this is going to be e to the 5th equals a. Okay, so we convert that to exponential, and we get e to the 5th equals a. The other one that you have to remember is common log. So let's say we have common log of 4 equals b, and we want to convert this to exponential. Well, to convert this to exponential, you have to remember what base common log is. Common log is base 10. If there's no base written there, it's implied to be a 10. Just like if there's no exponent, it's implied to be a 1. So common log is base 10. So the base is 10, the exponent is b, and this would convert as 10 to the b equals 4. Okay, so that's converting log to exponential. Now going the other way, you can convert exponential to log form. Okay, so let's try a few of these. Let's say we have x to the 5th is equal to 4, and we want to convert this to log form. So the base is x, and the exponent is 5. So we're going to have log base x of 4 is equal to the exponent 5. Okay, so log base x of 4 is equal to 5. So make sure the base of the log matches the base of the exponential, and the logarithm is equal to the exponent. All right, let's try, let's say we have 4 to the a is equal to 3. We convert this to exponential. The base is 4, the exponent is a, so we're going to have log base 4 is equal, log base 4 of 3 is equal to a. Okay, so the bases match and the log is equal to the exponent. All right, so you just follow in that pattern. Make sure you practice a bunch of these too. Let's try let's try one more. Let's do one with e. So let's say we have e to the 3 is equal to b. E to the 3 is equal to b. So when we convert this to exponential, we're going to have log base e of b is equal to 3. So if you want to, you can write it as log base e of b is equal to 3. Okay, so following in that same format, but remember we don't write log base e. It comes up so much it has its own name. It's natural log. We write natural log of b is equal to 3. Okay, so that's how you convert one with e in it. You change it to natural log. Remember, e and natural log always go together. All right, so let's see how to use logarithms now. If you remember, our first property was this one. We had log base a of a to the b is equal to b. That's property number actually, that's not on our list. Look at that. I'll have to make sure I add that back into the list for the final. So this was the first property that we looked at in 6.4, and this tells us how to simplify logarithms. What it says is that if you have an exponential and a log and the bases match, that they will cancel out and you'll be left with the exponent. So the logarithm says if your base matches my base, what is your exponent? The logarithm is the exponent. So for example, if we have log base 3 of 81, can we simplify this? Can we get these bases to match? Yes, we can. 81 is the same as 3 to the 4th. So the bases match, and the logarithm says what is the exponent? The exponent is 4. Okay, so that whole thing simplifies down to just the number 4. All right, one more. Let's say we have log base, what's one that we haven't done in a while? Let's say we have log base 2 of 8. Log base 2 of 8. So can we rewrite 8 base 2? 8 is the same as 2 cubed. So we can rewrite 8 as 2 cubed. Now the bases match, and the answer is the exponent 3. Okay, so that's a little bit of how we simplify the logarithms without a calculator.